Dear students, warm welcome to all. Today we are discussing the 10th chemistry class. The first chapter we are discussing here, it is periodic table and electronic configuration. So already you have studied about periodic table and the electronic configuration of elements in 9th standard. So this is a introductory part of that chapter. We are introducing the things that you are already studied in 9th standard related with atom and the electronic configuration and the atomic number and mass number, etc. So first of all, we are going to our chapter. The term is related with atom. Okay, we have studied that atom as the minute particle that have the entire property of the substance. It does not be decomposed or divided into subdivided, but later by the scientists they discovered that the atom contains protons, electrons and neutrons. And later we have know that the proton have positive charge, electron have negative charge, and neutrons are the chargeless particles. Okay, then we know that according to atom theory or atomic theory, there is introduced different types of characters related with atom. So now then later the Bohr model will be introduced related with the atom model. Okay, so the Bohr model introduced that there is a center part for an atom. That part is known as nucleus. The nucleus contains protons and neutrons. The nucleus contains protons and neutrons, and the electrons are revolved around the nucleus through a particular path. That path is known as shell. That path is known as shell. The shell is otherwise named as energy levels. Why they are called as energy levels? Because the moving electrons, the revolving electrons have a particular energy. That energy maintained in a particular shell or particular level. That's why they are known as energy levels. Or otherwise they are otherwise known as orbit. Okay, there are three names for the particular path. The first one it is shell, or otherwise it is known as energy levels, rather than that is known as orbit. Generalized we are again we are saying that they are known as shells. Okay, that's enough. The shells are named as K, L, M and N, like that. Okay, K, L, M, N. This is the cap we are represented as in capital letter K, L, M, N. This is K shell is the first shell, and L shell is the second one, M shell is the third shell, and N shell is the fourth shell. So I think you are familiar with these terms, shells K, L, M and N. Okay, again students, we are going through the Bohr atom model again and again. We are discussing that here nucleus is there. That nucleus contains protons and neutrons. Electrons revolve around the nucleus through a particular path. That path is known as shells. That path is known as shells or energy levels. So this is the nucleus. The shell near to nucleus is known as K shell. So that is the first one. Then second one L shell, and third one M shell, and the fourth one N shell. Okay. The energy of the shell nearer to the nucleus is comparatively very less. Lower energy shell is the K shell. The energy of the shells increases while move from nucleus. That means K have the least energy and L shall have the higher energy than that of K, and it is greater for M and it is greater for N, like that. This is the increasing order of energy of the shells. Okay, so again K shell is the first shell, L shell is the second one, and M shell is the third one, and N shell is the last one. Okay, then we know that each shell have the maximum number of electrons possible to accommodate in each shell will be different. That can be calculated by an equation that is also familiar to you. It is 2n square. That is 2n square. What is the n represented there? What is the n here? Yes, n is the period number, or we can say that the shell number or shell number. Okay, period number, other than we are saying it is shell number. So if you want to find the maximum number of electrons that are possible to accommodate in K shell, how can you find that? So K shell, you know that K shell is the first shell, first one. Okay, this is the first shell. The value of n here given as 1. Then substitute this value here, we get 2 into 1 square. 2 into 1 square, 1 square is 1, 2 into 1, that is equal to 2. So the maximum number of electrons are possible to accommodate in K shell, it is 2. Like that, we can find the number of electrons, maximum number of electrons accommodated in each shell. In L shell, if you give the values, we can get the answer 8, and M shell, it is 18, and N shell, it is 32. Okay, how you get that number 32 here? Because N is the fourth shell. Fourth shell means the value of N is equal to 4. So the equation is 2n square. So n into 4 square. Okay, 4 square is 16. 2 into 16, that is equal to 32. That's why we get the answer. The maximum number of electrons that are possible to accommodate in n shell, it is 32. Okay, you get the idea. The maximum number of electrons are possible to accommodate in K, it is 2, and the L it is 8, and the M shell it is 18, and the N shell it is 32. By using this, we can write the electronic configuration of an element or an atom. Before that, we want to know about atomic number. Atomic number. Okay, now we are just discussing atomic number. Again, I just told you this already you have studied in 9th standard. Atomic number. Atomic number. Atomic number is the number of protons or electrons in an atom. It is a number of protons or electrons in an atom, and generally it is there is that the number of protons in an atom, because the number of protons and electrons are equal in an atom, and the positive charge and negative charge are equal. That's why an atom is electrically neutral. So we are just saying that atomic number is the number of protons or electrons, because the protons and electrons are equal. Then it is represented, the atomic number is represented by the letter Z. Atomic number is represented by the letter Z. The next one, it is mass number. Mass number. Okay, the mass number is represented by the letter A. Mass number is represented by the letter A. And what is mass number? Mass number is the total number of protons and neutrons. Mass number is the total number of protons and neutrons in an atom. Again, atomic number is the number of protons in an atom, and mass number is the total number of protons and neutrons in an atom. By using this mass number and atomic number, we can find the number of neutrons in an atom. Number of neutrons is equal to mass number minus atomic number. Mass number minus atomic number. If you subtract the atomic number from the mass number, we can get the number of neutrons in an atom. In an atom, if you symbolize the atomic number and mass number, that if element is X, the symbol is not real. If an element it is X, we can write the atomic number at the left side, the bottom, it is set atomic number, and the mass number is here. Okay, so now we are going to discuss about the electronic configuration of an atom. Electronic configuration of an atom. For that, we are takes the atomic number 7. Atomic number 7. Atomic number 7 is for nitrogen. Atomic number of nitrogen is 7. Then if you write the electronic configuration, how you write that electronic configuration? The electronic configuration, if you want to write, the electrons are filled in a shell according to their energy. The electrons are filled in a shell according to their energy. That means the shell that have least energy will be filled at first. The shell that have least energy will be filled at first. You know the numbers. K shell, the maximum number is 2, and in L shell the maximum number of electrons are possible to accommodate is 18, and in M it is 8, in M it is 18, and in N shell it is 32. According to that, if you write the electronic configuration of atomic number 7, nitrogen, the first shell, how many electrons are possible to accommodate in the first shell? The maximum number of electrons are possible to accommodate in N shell, or in K shell it is 2. Then how many electrons are balanced there? 5. The 5 electrons are filled in the second shell. So the electronic configuration is 2, 5. This is the electronic configuration of atomic number 7. Do you understand the method to write the electronic configuration? The next, we are going to write the electronic configuration of sodium natrium Na. Its atomic number is 11. Atomic number 11. If you want to write the atomic number 11 is electronic configuration, you are just familiar with the maximum number of electrons are possible to accommodate in each shell. So that first shell, how many electrons are possible to accommodate in the K shell, first shell? That is 2. We have 11 electrons. Each electron want to fill in the shells. So the 2 electrons are filled in the first shell. Then the second shell, the maximum number of electrons are possible to accommodate is 8. So we are filled the 8 electrons in the second shell. So now the total number is 2 plus 8, 10. So one more electron is there, that is filled in the third shell. That's why the electronic configuration we can write 2, 8, 1. Okay, by using this we already find the group number, period number, and family of the element. That's already studied in 9th standard. How you find the group number and period number and family. In this case, we are finding these things for sodium. Okay, electronic configuration 281. First of all, we want to find the group number. How we are finding the group number? The group number can be found by using the number of valence, outermost electron. Valence means outermost, okay, outermost electron. So that is 1 electron in the outermost shell. 1 electron in the outermost shell. The outermost shell contains 1 electron. The group number is exactly 1. If the number of electron in the outermost shell is 2, the group number is 2. It is very easier. Then if the valence shell contains 3 electrons, you just want to remember that you want to add 10 with the number. Because if the number of valence electrons are 1 and 2, the group number is exactly 1 and 2. If the number of valence electron is greater than 2, you just add 10 with the number. Okay, then period number. If you want to find the period number, check the number of shells. The electrons are filled in how many shells? So, first shell, second shell, third shell. So, the electrons are distributed in 3 shells. So, the period number is 3. Period number is 3. Then, we want to know the family. We want to know the family. We want to know the names of each group. So here the group number is 1. The group number is 1. They are known as alkali metals. Students, please go through the names of families in your 9th standard to remember these things. First group are known as alkali metals. Second group alkaline earth metals. 3 to 12 they are known as transition metals. 13th group boron family. 14th group carbon family, 15th group nitrogen family, 16th group oxygen family, then 17th group halogens, 18th group they are known as noble gases or inert gases. Like that you want just to go through that chapter. Okay, family alkali metal. Then they will ask they are metal or non-metal. It is very easy here, alkali metal. So this element is a metal. These are the things we can identify or we can find whether you know the electronic configuration or the atomic number. By using the atomic number, we can write the electronic configuration and we can find the group number, period number, family, etc. As you have already studied, I think. Okay. The next one, you are going to write the electronic configuration of atomic number 18. Up to here we have studied atomic number 18, it is argon, argon, that is element. Okay, atomic number 18, argon. Okay, we are going through the electronic configuration here. How you write the electronic configuration? The electronic configuration is 2, 8, 2, 8. Now how many electrons are filled? 2 plus 8, 10 electrons. The maximum number of electrons are possible to accommodate in the second shell, it is 8. Okay, so 2, 8, 10. How many electrons are balanced there? It is 18, 8 more electrons. So the 8 electrons are filled in the third shell. So the electronic configuration is 2, 8, 8. By using this, just find the period number, group number and the family of the element. Just find the period number, group number and family of the element. How can you find period number? Just want to find the period number, just check the shells. How many shells are there? 3. So the period number is 3. 1, 2, 3. Then group number. If you want to know the group number, valence electrons 8. 8 is greater than 2. Just add 10 with the number. So we get 18, that is 18th group. Third period, 18th group. Family, 18th group are known as noble gas. Noble gas. So they will ask whether it is a metal or non-metal. What is your opinion? Whether it is a metal or non-metal. Is it a metal? No, this is a non-metal because noble gas. So non-metal. These are the things we can easily find or identify if you know the atomic number. For the easiness of these characters, the elements are arranged in a periodic table. Okay, listen. The one more question is to write the electronic configuration of atomic number 19. Atomic number 19, it is potassium. K, kalium, this is Latin name. From there this arrived the K, so potassium. Atomic number 19. How you write the electronic configuration? Some of the students write the electronic configuration as 289. 289. But some of the students, they write the electronic configuration as 2881. Why this difference? And some of them, the exact electronic configuration of 19 is here, 2881. If you write this, some of them will ask how it will be wrong. Because the first shell, maximum number of electrons are possible to accommodate in first shell, it is 2. In second shell is 8. In third shell, teacher, that will accommodate maximum 18. Then why the 9 electrons are not possible? Okay, the maximum number of electrons are possible to accommodate in the M shell, third shell, it is 18. Then why? The 9 will be possible. Then why we are writing as 2881? Do you know the answer? So the answer is our chapter. The answer is our chapter. We are going to take our chapter is from here, from this electronic configuration, 2881. Why this difference? We are not write like this. Why we are writing like 2881? So further, the scientific explanation for this electronic configuration will be get while we are explaining our chapter. Okay, students? Thank you.